My name is Joseph Hermosillo and we'll be going over synovial joints here in this video. In this picture you see a femur and a tibia. Right in the middle in the light green is a synovial cavity. This synovial cavity can also be said as a synovial joint, which is one of the most common joints in our body and helps these two bones, as in this example, articulate with each other, and the muscles that help them articulate either at their origin or insertion of these muscles. The synovial cavity has a major role in that. Synovial cavities are made up of multiple membranes or cartilages that help them attach to these two bones and provide for that little cavity between them for that synovial fluid to reside in. In this other picture right over here, we see a close-up version of this previous picture. Again, light green is the synovial cavity, but now we see in more detail the articular cartilage in the middle, which is this orange that attaches the periosteum of the bone to the synovial cavity itself, as well with the articular capsule, which is the whole house or home of the synovial fluid. As mentioned before, synovial joints are one of the most common in our body. They also happen to be diarthrosis in nature, which means they are freely movable, so their range of motion is pretty high, and that helps a lot of our bones, such as our femur and tibia, to articulate with a lot of motion in either the forward or backward direction or side to side. Here are all the representations of the different joints in our body. The two major ones that a person would think of when they think of joints are ball and socket and a hinge joint. Hinge joints are found at our elbow, and they're just what the name says. It's like a hinge allowing our elbow to articulate upwards and downwards from the anterior to posterior positions. Ball and socket, on the other hand, would be found at our femur connecting to our os coxa. This ball and socket is just what the name says. One of the bones, which is the femur, the head of the femur rather, is shaped like a ball, and the acetabulum of the os coxa is a concave socket that fits perfectly in there. Our other four joints consist of pivot joints, here found in the neck, where the red part here characterizes the odontoid process of our axis, and the purple is our atlas that pivots around that process, allowing our neck to slide to side. Another joint would be the condyloid joint found in the hand, which allows you to wag your finger back and forth. The plane joint found in the tarsals of our foot is just what it sounds like. It's two bones sliding against each other just like a plane. And lastly, our saddle joints are just what the name suggests. One bone is shaped like a saddle, where the other bone sits right on top of it. That is found in the carpals of our wrist. Range of motion refers to the amount of motion that these joints allow our bones to have. So when our bones articulate with each other, each different joint can only withstand so much range of motion. Our ball and socket joints have the greatest range of motion, which is why also a lot of people immediately think of ball and socket joints as the most common type of joint here found in our hip or in our shoulders, for example. Lastly, we'll be talking about levers. There's three different kinds. Our first class lever, I say first class, you say seesaw. That's because our fulcrum, which is our joint, is in the middle. Our load, which is our resistance, is on one side, and our applied force, which is also known as effort, is on the other side, and thus creates this picture of a seesaw where it is in balance with the fulcrum being our joint in the middle. This can be found in your neck. So when I'm falling asleep in class, my head tends to go forward because of the weight, but the muscles in the back of my neck tend to pull it back up. So that is the seesaw, with my fulcrum being my atlas and axis joint. Moving on to the second class lever, this is a wheelbarrow. So when I say second class, you say wheelbarrow, and that's because our fulcrum is what we would see here as the wheel Our effort is us pulling up on the wheelbarrow, and the resistance is the weight in our wheelbarrow. This is found when we are doing a plantar flexion in our foots. So I put my toes into the ground, and my weight of my body is the resistance. The fulcrum is down here at my toes, and the effort is my muscle flexing as I pull up on it. And lastly, our third class is a little hard to demonstrate with something like a wheelbarrow or a seesaw, but it's really easy if you see it in a body where our fulcrum is our elbow joint, for example. There's a weight in my hand that I'm doing weights with, and my brachial muscle will be doing the effort. So when I do a curl, the third class lever is characterized by this motion of me making the weights. And this is actually one of the very most common levers in our body. One last note about the levers is the mechanical advantage that they each create. And this is basically the ratio of the input force contrasted to the output force that each lever allows for our joints to have. So each lever will consist of different mechanical advantages, since each lever is different in the way that they help the bones articulate.